The definite integral has a lot of properties, so let's take a look at number one. So here is a function, and this is a, and I'm asking the integral from a to a from f of x dx. What could that be? The area under the graph between a and a. Do we have an answer? Well, since there is no width of the interval, the answer is 0. And number two, the integral from a to b from f of x dx is the same with the opposite when I reverse the limits of integration. These are the limits of integration. So a and b are called limits of integration. Of course, f of x dx. The next one, number three, very popular, the integral from a to b from a constant times a function dx. The same property is we had for limits. C goes in front. So this is C, the integral from a to b from f of x dx. As long as this is a factor, of course. Any questions so far? Okay, thank you. So number four, odd function and symmetric interval. If both conditions are fulfilled, so let's take a look. So I'm going to graph an odd function, very popular odd function. And I'm going to create a symmetric interval between negative a and positive a. And now I would like to determine the integral from negative a to a from f of x dx, knowing two things, that this function is odd and the interval is symmetric between negative 5 and 5, between negative 3 and 3, between negative a and a. What do you think this will equal to? The answer is, this is the positive area, this is the negative area. They must be equal because the function is odd. So then the answer must be 0. Next, same thing but for an even function. So even function and symmetric interval. So let's take a look. Here's a very popular even function. And now I'm going to create a symmetric interval. So the integral from negative a to a from f of x dx, so this is when a function is, this function is, I'm sorry, even, of course. That's what I meant. When the function is even, what do you think the answer would be? So these are both positive and both equal, right? So it would be twice the integral from 0 to a from f of x dx. And why is this so important? Because looking back at what we looked at All of these had different, except this one. See how easy this is? When the lower limit is 0, this goes away. Most of the time. Not always, but most of the time they go away, right? But now here, when I had the integral from 1 to 2, I had to plug in 2 and then subtract when I plug in 1. So, but this is possible only if the function is even and the interval is symmetric. Otherwise, this property doesn't work. It's not applicable. So it's always easier to determine the integrals from 0 to a number than from -5 to 10 or from 2 to 9. Okay, next property, number 6. Let's take a look at this graph. So we have a function. Here's A, here's B, somewhere here is C. Is there any way I can determine, so this is function f of x. So is there any way I can determine the integral from a to b from f of x dx in a different way? What do you think? It's the same with the sum of two integrals, one from a to c and the other one from c to b. Of course, from f of x dx. Another property that we've seen in limits, similar property in limits, we have the integral from a to b from f of x plus or minus g of x, of course, dx. What do you think this will equal to? Same thing with the limits, the integral from a to b from f of x dx plus or minus, if this is plus, this is plus, if this is minus, this is minus, the integral from a to b from g of x dx. Property 8. Let's say the integral from a to b from a constant dx. You will say you just showed us this, that the function, the constant goes in front, correct? So now I have 1, I have to have something, and that's the only thing I can have. And now the question is, what function prime is x? What function prime, I'm sorry, my apologies. What function prime is 1? Yes, it is x, of course. So this is c, I plug in b, minus when I plug in a, and this is it. Any questions so far? Okay, property 9. If a function is always positive on the interval a comma b, what do you think about the integral from a to b from f of x dx? If the function could never be negative on an interval, its area or the integral must be positive, for sure. Property 10. Let's suppose we have this scenario. We have a function which is g of x. And let's say I have another function which is f of x. And the interval is ab. We notice from here clearly that the function f is above function g on the interval a comma b. So f of x is greater than or equal to g of x. Or if you want to write it vice versa, it doesn't matter. G of x is less than or equal to f of x. Then what is the relationship between this area and this area? Well, of course, the same thing, the integral from a to b dx, the integral from a to b dx. So the relationship now, let me write it one more time so we can see it. The integral from a to b from g of x dx must be less than or equal to the integral from a to b from f of x dx. Every time g of x is less than or equal to f of x on the interval a comma b. If a function is below another function on an interval, its area must be lower than the area under f of x. Any questions? Anyone? Okay, I have number 11. Let's take a look at this scenario. Here's function f. Here is a number m. And here is a number uppercase M. These are straight lines. Obviously from here on the interval a comma b, I can immediately write that f of x is between lowercase m and uppercase m. There is no discussion there. Therefore, this area is smaller than this area, which in turn is smaller than this area. All I have to do is put the symbols. But we just determined this a minute ago. Just instead of m, we had c. And we determined this a minute ago, and just that instead of uppercase m, we had lowercase c. So then, can anyone give us these two sides? What will this be and what will that be? And then I would like to look at some applications with the properties and also an example in which we can determine the antiderivative. Only a mathematical software can do it. So obviously this is what we just did on a few minutes ago. So this is m b minus a less than or equal to the integral from a to b from f of x dx. And of course the same thing, uppercase m b minus a. This is the same with this property. Instead of c, I have lowercase m or uppercase m. Okay, I think we covered it all. So now let's try and practice different problems using the properties of the definite integral. Any questions? Have you found anything else for me before we look at applications? How to apply the properties of the definite integral. Okay, here's an example. I'd like to start with 44 on page 395. We have the integral from negative 2 to 2 from f of x dx. This is what we are asked to determine. And they're giving us f of x as 2 when x is between negative 2 and 0, and 4 minus x squared when x is between 0 and 2. So, any suggestions for me? How do we determine this integral? Well, since we are asked between negative 2 and 2, remember one of the properties that we just looked at a few minutes ago, which is this one. the integral from a to b can be determined as the sum of two integrals between a and c plus the integral from c to b. So this is the property that we're going to apply here. So the integral from negative 2 to 2 from f of x dx must be the integral from negative 2 to 0 plus the integral from 0 to 2, of course something dx. So from negative 2 to 0 the function is 2. From 0 to 2 the function is 4 minus x squared. So now I calculate, I determine the antiderivative of 2. Well, 2 goes outside and I have 1. So I know that that is x from negative 2 to 0 plus the antiderivative of 4 is 4x minus the function that I differentiate to get x squared is x cubed over 3. And this is evaluated from 0 to 2. Let's take a moment and we haven't finished, but let me see if you have any questions. Any questions here? Anyone? Any questions? Okay, so when I plug in 0, I get 0. So when I plug in minus, when I plug in negative 2, so 2 times negative 2 is negative 4. Plus, when I plug in 2, I get 8 minus 8 divided by 3, minus, when I plug in 0, I'll get 0. So there is no need. So this is positive 4 and plus 8 minus 8 over 3, so this is 12 minus 8 thirds. In other words, 36 minus 8 divided by 3. So that is 28 divided by 3. So we apply the property that allows us to split the integral into two integrals or vice versa. Add two integrals to determine the bigger one. Okay. Let's see another. I'm going back. Okay, so let's take a look at 57 on page 384. They're asking us to show that this is correct. 2 less than or equal to the integral from negative 1 to 1 from the square root of 1 plus x squared dx, of course, less than or equal to 2 the square root of 2. We don't know how to calculate any of such integral, but we're not asked to find anything to calculate the integral. We are only asked to use the properties of the definite integral to show that this is correct. That's all we want. So my starting point has to be here. I have to identify the fact or present the fact that we are interested in is happening between negative 1 and 1. So that's our x. I'm trying to build this function.
So I have the x. I'm not allowed to square in an inequality like this. However, I know that if x is between negative 1 and will be a positive number. Positive number, what would be the Limits, left and right. Well, if we look at the following graph, so for the interval negative 1 to 1, when I square here, when I get for x between -1 and 1 and I square, I know now that x squared is a positive number, but it will definitely be between 0. For any x value between -1 and 1, x value of x squared, I should say, the y value, x squared will be between 0 and 1. So every time x is between -1 and 1. Why do I need this? Because I see the
x squared inside the square root. Of course, 1 less than or equal to 1 plus x squared less than or equal to 2. Now, all these are positive numbers. We never take the square root or apply the square root in an inequality. But since they're all positive, we are allowed to. So the square root of 1 is 1. The square root of 1 plus x squared is just that, less than or equal to the square root of 2. I didn't mean that, I meant this. So apply the square root to all three sides. So the square root of 1 is 1, the square root of this is itself, and the square root of 2 is the and the integral from this is less than or equal to the integral from this, and it must be the integral less than or equal to the integral from that.
So back to our, oops, I took the page. So
to 1 dx. And let's see what we get. The left-hand side, remember, is 1.
Is this minus this. So it's 1 minus -1. Less than or equal to the integral from -1 to 1 from the
square root of 1 plus x squared dx. And less than or equal to, and we know that this is the square root of 2, and in parentheses the same thing, 1 minus -1.
So finally, we have, and this is 2 times 1, which is 2, the less than or equal, and this is 2, the square root of 2, and this is exactly what we were asked to show. That 2 is less than or equal
to this integral, which is in turn less than or equal to 2 the square root of 2.